What's up everyone? In this video we're going to deploy FTD on high availability, meaning active standby, and we're going to set FTD 27 as the primary, and initially FTD 28 is going to be the standby. Similar to what we have done so far, the G0 interface is going to be the outside, and we're going to have BGP session with R1, and R1 is injecting a default route towards the sensors, and they will have OSPF adjacency with R6, and so that local network, when they try to reach R1, they going to be translated to the sensors outside interface. So in this case, we're going to have the same IP whenever FTD 27 or 28 is the active unit. So let's start the configuration using FMC. So first we have to add FMC as the manager on these units. So configure manager 92.168.43.112 and the key, and have to do the same for the second unit. And going to be configure manager and 192.168.43.114 CCIE 65745, and D27. Okay, still loading. So let's go over devices, and I'm going to open actually two tabs. We did this in last time. Make sure. Okay, this is done. So let's start with 27, and so it's going to be the IP 192.43.113, and name is going to be 27. Registration key is the same we used, and the group, it's going to be firewall group. ACP, I'm going to create a new access control policy and name it FTD policy. So there is no base policy. I'm going to save this, and by default it's going to block all traffic. And let's see FTD 28, it's done as well. Oh man, sorry. My bad. I hope it didn't accept that. Yes, so it has to be 12, not 14. Yeah, and going to enable those features. And let me double check. So that's the IP, I'll display name, firewall group, FTD policy. Okay, let's begin. And FTD 28. So while it's loading, you can start. It's going to be 192.168.43.114, and that's going to be FTD 28. The registration key 65745. Group is going to be firewall group. The policy already exists, and confirm. Okay, was configured. You can start the registration process. Now both devices were added successfully. Then now let's try to create the high availability object. So going to add high availability, going to name it FTD HA, And device type is going to be threat defense. And the first unit is going to be 27, it's going to be the primary. And the second is going to be 28. So this is going to restart, snort process. And right now, the high availability link we're going to use is going to be E0. This is going to be the failover link and the state link as well. So I'm using these windows, so it's G02, and let's just give it a name, failover. Now the primary IP, this is the address that is going to be used to monitor the link. So I'm just going to set 192.27.28.27. And the secondary IP is going to be 192.27.28.28. Same network and the mask. And state link is going to be the same as LAN failover. So I'm going to add. Now the high availability configuration is completed. So let's take a look. What do we have now? So we look at summary. We should see a primary peer S27 and standby FTD 28. So what do we want to change here? So the standby IP, you can see, doesn't show. And if we look at this CLI, we should show failover. We can see that currently this is the primary unit. It's using G02, and we're going to change those values for quick detection. But what I want to highlight is the outside interface and the inside interface. You can see it is not being monitored, and the standby unit doesn't have any address configured. So let's change this. And outside interface, so we're going to assign an IP address for standby unit. It's going to be 2728, and the same for inside interface. So it's going to be 10.6.27.28. Okay, and what we want to change is for fast detection. Let's adjust those values. So I want to send every 5 seconds, and the interface poll to be 1 second, and the hold to be 5 seconds. So as fast as possible. I believe the peer can be detected in 3 seconds. Yes, in 3 seconds. Okay, that's okay. Let me save this. Now we have to configure OSPF and BGP as well. So PR1. So R1 should be expecting only 27, so we can. So first let's start with OSPF. So OSPF is going to be an internal router, and we want to inject default routes, and area is going to be area 0, and the network is going to be 10.6.7. Now the interface, where is it? It's going to be inside interface, and that's it. As for BGP, AS is 64500, and neighbor. And the neighbor is going to be 192.127.1. ASN is going to be 1. And I want to enable AFI. Going to press OK and just double check that we have everything in place. So that's the neighbor, AS number, AFI. Yes, everything looks okay. So let's save this. And before deploying, let's configure NAT so that these networks 1007 get translated before reaching R1. So open here, NAT, threat defense NAT, and it's going to be FTD NAT. Let's grab this object and let's create the policy as well. So just use this step. So we're going to create a very basic. So we have to assign those interfaces to the respective zones. So we're going to do this in a moment. So right now, the source interface is going to be from inside to outside. And the translation, let's just use AutoNet and dynamic. So traffic source from 1007. I have this object here. Yeah, I have to add again. So this is going to be the destination, this is going to be the source, and here I want to use destination interface IP, meaning the outside interface of the active unit. So advanced, nothing else. And that's going to be unidirectional. Yeah, that's what I want. So let's save this. Now go back to device management, and we have to assign the interfaces to their respective zones. So outside has to go to outside zone, security zone, out. Going to save this, and inside should be assigned to in zone, and that's it. That's okay. So we can save this and jump back to our policy. So let's create a very basic policy allowing 1007 to reach R1 for HTTP, HTTPS, and ICMP. So just going to name it allow internet, and going to be a source from inside, destination outside, and networks going to be 1007. Going to be my source network, and the ports are going to be HTTP as the destination, and telnet as destination, and let's use ICMP as well. And let's log this rule at the beginning of the connection, and that's going to add this. Allow internet sourcing from inside zone to outside zone, and this network on these ports or applications. So I'm going to save this, and we should be good to deploy those changes. So let's expand this. Everything looks ready. So let's deploy this and then look at the changes. So meanwhile, we're going to test the failover by shutting down a data link interface so that FTD 28 or the standby unit takes over the role. So let me put this. And actually different conditions that could trigger failover. This is one of them. And to make this process fast as possible, I've configured the interfaces with port fast. So this way it's going to speed the process of from shutting down. And that's what right now I have O2 down, so that's not good. So if I issue the show O2, so we can see right now it's already forwarding state because I'm using port fast. So it's being deployed right now. I look at see what's current status. Active, and it's still waiting. Oh yes, because that's we're deploying now. Okay, so going to give some time to process. So the policy was deployed successfully, and if we look at the interfaces on the active unit, right now we see that the interface and outside are being monitored. So same applies to the standby unit. So now let's test reachability using 34 and 35. Bring this here. Really? And so we're going to try to telnet to R1, and should be 11111, and that's successful. And right now this is the outside interface of the active unit, and if we ping 1111, that should be successful as well. So right now I have the switch in place, and what I'm going to do is to shut down E01 interface. So this is going to trigger the failover to FTD28. So I will keep the telnet session and going to send a bunch of packets using 35. So repeat max and timeout 1 second. Now if I shut down, let me see if I can show the, if I shut down E01, so it's going to fail for a couple of seconds there, and we can see, so right now the standby unit now should become the active one. And we show failover. So right now this unit failover is the secondary, and let's see, and is the secondary and the active one. And you can see that ping still working. We lost a couple of packets there, and telnet session didn't drop as well. And we can confirm this on FTD, on FMC. So if we get to summary, we should see now the primary one should be 28. Oh, actually 28 is the active, and the primary failed. Okay, so let's bring it back. I switch if I issue no shut. So it's back up and should see switching. Okay, so it is okay, and now we can so now let's change the role to the other unit. We can do this using GUI, and let's go to the main tab, and here where is nope we change each active peer here to make 27 the active peer. Yes, let's do it. And it's done. So right now the active is going to be the primary FTD 27 telnet session. It's hang for a while but didn't drop, and we lost a couple of pings there during this transition. And so that's it, guys. High availability on FTD. I hope you guys enjoyed, and I'll see you in the next one.